Hello, this is Maria from Math Mammoth. In this lesson, we're going to look at rotations in the coordinate grid. Let's review what the rotation is. In a rotation, we have a point that is going to move along a circular arc around another point called the center of rotation. For example, this point now, as I rotate it, it moves around this arc of a circle centered at this center point. And rotations are measured in degrees. So let's say, for example, if I have my point that has been rotated all the way here, then I can draw an angle here and measure it. And so it is about 138 degrees, that particular rotation. Something special happens when we rotate points in the coordinate grid and we rotate exactly 90 degrees. Let's look at that. Here I have two pink points, and one of them is rotated 90 degrees from the other around the origin. And I'm going to show you that using my angle measurement tool. Okay, that angle is exactly 90 degrees. But now look at the coordinates of those points. This point here, 2, 5, when it's rotated 90 degrees, it becomes 5, negative 2. It is as if these numbers were flipped. 2, 5, and then 5, 2, but one of them became negative because it is in this second quadrant of the coordinate grid. If I take this point and rotate it again another 90 degrees, where is it going to go? It's going to go over here, where now it is negative 2 and negative 5. So again, we have 2 and 5, but now they're both negative. And then if it's another 90 degrees, goes over there, and now it is negative 5, 2. So every time the coordinates were 2's and 5's, and that gives us an easy way of figuring out the coordinates of rotated points if they are rotated 90 degrees around the origin. We just need to carefully look at which quadrant of the coordinate grid they are in, and use that then to determine whether the coordinates are negative or positive. Let's look at another point also, this brown point. So this one, if I rotate it 90 degrees around the origin, and let's go counterclockwise this time. What are going to be its coordinates after the rotation? Right now the coordinates are negative 4 and negative 1. It's going to move into this quadrant, and after 90-degree rotation, it's going to be where? Yes, at 1, negative 4. And again, another 90 degrees at 4 and 1. You see how the coordinates are just switching between 1 and 4, 4 and 1, but you need to check whether it's negative or positive based on in which quadrant it is. Previously, we rotated points around the origin in the coordinate grid. Now we're going to look at rotating points around other points, not the origin. Essentially, the concept is the same. If I have a point here, and I rotate it around the brown point, it goes around a circular arc, and the circle is centered at this brown point. Now let's think that if I rotate this exactly 90 degrees clockwise around this point, where is it going to go? It's pretty easy to see. 90-degree angle would be here, right? So it's kind of like following the grid lines. We go down to this center point and then 3 units here. This is where it's going to be after 90-degree rotation. So we can use the grid lines and count units to figure out the coordinates of the point after such a rotation. It's going to be at 4, negative 2. What about if it is 90 degrees counterclockwise? Where would you say it will go? Yep, that's easy. It goes here to negative 2, negative 2. You can think of it moving first to the center point and then 3 units over there. Now lastly, let's rotate this triangle 90 degrees clockwise around that given point. Let's figure out where these vertices A, B, and C go in such a rotation. Now A is easy, okay? It's right now 1 unit from this center point of the rotation. So moving it 90 degrees, it'll go over here. So that's our A prime. And then B is easy too because it is 4 units, exactly 4 units up from this center of rotation. So it'll be 4 units this way, right? 1, 2, 3, 4. B prime would be here. But where's C gonna be? That's a little trickier because C is not exactly left, right, up, or down from the center point. The easiest way that I see to figure out where C will be is to think its relationship to A and B. How to get from A to C using grid lines. From A to C, I would go 1 unit this way, 1 unit towards B, and then 4 units over there. This whole triangle will go kind of like that in the rotation. So if I go from A prime, the image of A, towards B prime, just 1 unit, and then 4 down, like that, that's where C prime is gonna be, or the image of C under this rotation. All right, let's try now. Since I have this program, I'm just gonna rotate this entire triangle using the program's capabilities. Pretty good, right? Okay, that was all for this lesson. I hope it was helpful.